Hello all and welcome back. So in this video, let us continue our discussion on dynamic programming, and now let us understand another way through which we can solve questions using dynamic programming. Now in the last couple of videos, I'm pretty sure that you must have gotten a basic idea on what exactly dynamic programming is and how it helps us to solve questions in an optimized manner. Along with that, you should also understand the basic idea, the intuition behind dynamic programming, and that is exactly the same as we discussed in the first video. That is, if we have overlapping sub-problems, basically sub-problems which are getting solved again and again, we should save their solution once we have solved them. Okay. So that's the basic idea behind that. Pretty sure you must have also written the code yourself. Moving forward, I will be giving you many questions which you will be trying, and then a lot of fear which you might have for dynamic programming will just be away. Just one thing to please make sure is that try that your recursion overall approach as well as the concepts are a lot clear, because for dynamic programming recursion is required. You cannot do DP without knowing recursion. Okay. So in this video, I want to talk another approach to solve the same question, or rather to solve dynamic programming questions, right? Now, it is normally known as dynamic programming approach. The first one which we learned was a memoization technique, right? Where we were adding memory to our recursion. Now, when we are given to find a Fibonacci number, how do we do it ourselves? Like when, if we don't have to use any particular, let's say code or anything, let's see how exactly do we solve that particular question. So let's say you ask me what is the fifth Fibonacci number, right? I will be writing down the first two, 1, 1. Then I will say that, okay, I have these numbers. Then let me add 2 here, because 2 is which what I get after adding two ones, right? Then moving forward, so let me draw it like this, so it is a lot clear. Now I will write down 3. Now I can write down 5. And let's say this is overall 0, 1, 2, 3, 4. And if we needed to find the fifth number, fifth Fibonacci number, that is going to be 8, right? If you will pay attention, I have worked in this particular manner here, right? As compared to our code, the recursion code which we wrote, here what we were doing, let's say we wanted a particular number. So for example, 0, 1, 2, 3, 4, 5. For getting the fifth Fibonacci number, I used to call directly on recursion. I used to call directly with my function where I used to keep it Fibonacci of 5, right? Then after that, what we used to do, once I get on 5, I used to see for the last two numbers if I have them or not. Similarly, this used to see the last two numbers if it has or not. 2 used to see for 1 and 0, and 1 of course we used to have, so there we can write down the base case. Base case used to be 1 and 1, right? So this is the overall your base case. But I'm pretty sure that you must be able to see the difference. The difference is that when we are solving using memoization or recursion, we are starting with our answer. We are starting with the top most value which we need. Whereas when we have to ourselves solve it, or I should rather say that there is one more very different way of solving this particular problem. That is if I start from bottom. Okay. Now the sub problems are the same again. Getting the Fibonacci of 2, Fibonacci of 3, Fibonacci of 4, all these are same. You will be having the same sub problems. But this time, instead of starting my overall approach from top, which I did in the right side, where I started with 5, I am trying to build up my answer from the bottom. Okay. So this approach is actually known as dynamic programming approach or the bottom up approach. Okay. So let me write that down. The idea, I hope it's clear. It's known as bottom up. And this particular approach is known as top down. It is also known as memoization. Okay. and this one is known as tabulation. Tabulation. Normally, it is also called as pure TP, but I think tabulation is better to not confuse us. But I hope you are able to get the basic idea. In this, overall, what we are aiming to do, we want to calculate the answer from bottom. Okay, so let's go down and we will see the code as well. But first, let us discuss few things. What exactly will we be doing? We started with when we wrote the recursion code for our problem, right? So we first write the recursion code. Then after that, what we did, we were using recursion again, but this time in line with the principle of dynamic programming, I added a memo array or memoization in which we were solving the solution, storing the solution, storing sub problem solution. Now, given any particular DP question, right, the best identifier if the question can be solved by a DP or not is actually if you see overlapping subproblems, right? The same which we were able to see in your Fibonacci. One thing more, always you have to make sure that you first write the recursion code, then you make the memo array, okay? So as to do the memoization. In that, if you just add 4-5 lines just to save your solution, you will be very good to change your whole DP, whole recursive code into a well optimized memoization or top down approach, right? In the last approach, what we are expecting is that we need to get rid of recursion altogether. So we want to just do a bottom up or tabulation approach. Okay, so here what we want, no recursion, directly solving or storing the solution. And I hope you get the basic idea here as well. When what we did, when I asked you to calculate this yourself, right? So we were not using any recursion or anything, right? We were just using an storage. You can call this as a list or something. And using that, we were able to get to our answer, right? So nothing like recursion we were using. Even if you ask a school children would have never heard of recursion, he can solve this question in this way. Okay. So let's see everyone how we are going to write the code for this. So let's say def Fibonacci, and please make sure that you're understanding the basic idea. My whole approach in explaining you like this is to make sure that intuitively the idea is clear. Okay, great. So this time what I'm going to do, I normally try, or the way I used to keep their name is I use DP. Okay, so I normally use DP if overall, 1 minute, let me just do 0 into n plus 1. So whenever I'm writing this bottom up solution, I use the name as DP. And for a memoization solution, I use memo as a array name. Just something to remember. There is no hard and fast rule for that. We used the diary in the last video so as to make sure that you were able to understand that. But normally going forward, I will suggest to make sure that you are able to differentiate the approach you have followed. Please make sure that you also fix a name. Now, what I will be doing, everyone, I will be calling this Fibonacci number with, let's say, 5 or n rather, and I get my answer. In this, I'm just going to now print my answer. Great. I can send this DP as well. That should be fine. I think I'm just sending this DP list. I am initializing it with 0 and n plus 1. Okay. Great. Now let me try to just solve this particular question again. What exactly will we be doing here? Okay. So pay attention. If n is less than equal to 1, we can just return 1. But before returning, I will try that I am saving this particular question. Okay. So saving this particular answer. So dp of n equals 1. Let us try to understand this. I had these when I started up, right? So let me just draw the dp array and let me help you visualize how are we going to fill this up in a bottom up manner. So pay attention everyone. This is, let's say, our dp array. Okay. What I'm doing effectively, this is the 0, 1, 2, 3, 4, 5, and 6. Okay, so let's say we are talking about 6. I just want to make sure that you get the basic idea that how exactly is this happening. For the first two, I know the answer, right? Again, you cannot tell me the second Fibonacci number if I don't give you the first two. Something which we have seen in recursion as well, right? There were two base cases. First time we used two base cases. So effectively, if you don't have two numbers, the last two numbers, you cannot tell me the second number. What is here? Okay. Similarly, if I ask you directly for 4, you cannot tell me unless you have these two available with us, right? So we cannot say that, hey, this is the fourth Fibonacci number before having these two numbers. So the whole idea is that let us take a number and understand where the dependency lies. For 3, I know the dependency lies on these two. Okay. So once we have understood this, then let us try to understand the constraints or the base case as well. Let me write that down. Understand base case. Understand base cases. Okay. So let us try to see this everyone. How can we do that? I know these one are my base cases. Base case 1 and base case 2. I can directly go and fill these in my array, in my list. So what can I do here everyone? Actually, we can get rid of this. Instead, dp of 0 equals 1, dp of 1 equals 1. Now these I am writing because I know the answer. They are the base cases. Now let me fill this particular list in a bottom up approach, starting from the bottom, filling each and everything which I can actually fill because I have the dependency. For example, for 2, the dependency is these two numbers and I have both of them. So I can very well write my answer for 2, which is going to be 2 here. Now if we move forward for 3, again, the dependency is on these two values. I can just add them and fill them here. And it's going to be 3. Right, everyone? So let me do that. First, we have to make sure of one thing as well. We can actually not, we can send this DP inside as well, should be fine if I am initializing it by 0. Or the better case will be to make it proper code. I think I should just define it here. So 0 into n plus 1. Okay. Again, this time I will not be using recursion. My idea will be based on understanding of recursion. So everywhere you will be filling up your base cases and then see that what all are the different sub problems which you can solve. What do I mean by sub problems here, everyone? If you see this 3, it's also a sub problem, right? Fibonacci number, which is on third position, it's a sub problem of my answer Fibonacci on sixth position. So let me do this thing. Let us do 6. Great. Now I can start my loop. So for I in range 2 to n plus 1. So I have to make sure that I go till 6. N is 6. Thus, I have to make sure that I add plus 1 there because it's a range function. Okay. Now let us pay attention everyone. What do you think dp of 2 should be? Let us first write for dp of 2. dp of 2 should be equal to dp of 1 plus dp of 0. In a similar manner, dp of 3 should be equal to dp of 2 plus dp of 1. dp of 4, right? So I hope you're able to understand this. Let me just write that down as well. dp of 0 plus dp of 1. This will be 1 minute. dp of 2 plus dp of 1. So all I am doing here is to make sure that any subproblem which I'm able to solve, because all the dependencies are clear, I am just solving that and filling up my table, filling up my DP array or a list. Okay. So this again I can write in a similar way as DP of 3 plus DP of 2. So this can be DP of 4 plus DP of 5, DP of, sorry, 3. Similarly, the final one, I can just directly say DP of 5 plus DP of 4. So if I'm able to just solve and fill up my whole array, I can say that, hey, this is going to be my final answer. Right, everyone? So I hope you're able to understand this. If I just keep on filling this particular array or a list, then in the end, I can very comfortably say that this is the final answer. Something which we will now do. I hope you are able to understand that how this particular depends on these two. These two I need to have. Without having them, I cannot actually solve or get any Fibonacci number. Similarly, 3 depends on these two, 2 and 1. 4 depends on 3 and 2. So one by one, I am trying to just make sure that I fill up all the things which I have a dependency cleared. For example, once I fill in 2, I can get the 3 because these two are the numbers. Then once I fill in 3, I can get these. Right, everyone? So I hope you are able to understand that how just I am trying to codify or add code to the solution or the approach which we were solving when we were getting the answer in our mind or when we used to get the answer. So the idea is exactly the same. This is the approach which we used to follow when someone asks you, you are not using recursion or anything. But again, to write these kind of solution, these pure DP solution or tabulation solution, we have to understand recursion very well, because as we move forward, the way this particular list gets populated, it's going to be a lot dependent exactly on how well you understand the recursion code. If you remember in the first video when we wrote the overall recursive or the memoization code where this was diary, pay attention everyone how exactly the list, the diary gets populated. Everything is -1 initially. First we are calling for n5. This is the n5. Let us move forward. Now we are calling for n4. This is n4. Now for n3, then 2, then 1, and we used to then fill up for these 0 and 1, right? Because these are the base cases. So just that I started from 5 here, top, down. This time I'm starting from bottom, bottom, up. So it's the direction. I start from top and go down, start from bottom and go up. This is just the difference which I'm using to do my solution in a different way altogether now. The reason I am explaining you this with so much patience, with so many repetitive statements, is I want to make sure that this sits in your mind always. Okay. Many students, they just understand it very quickly, so they are not able to comprehend how exactly the solution is getting built up. And that's why I always make sure that in DP, visualization is of most important. Okay. Visualization is the most important thing which we can use. Now, in my solution, I'm just filling it like this. So same thing is going to happen. Here first, you will see that we will have 1 here. Okay, so pay attention everyone. Initially 0 and 1 will only get populated. So see, first we have 1 here. Now we are going to call for 0 and 0 and 1 are filled. Now 2 will get filled, then 3, then 4. Okay, just that I am filling up in this way, but I called from the 5. So calling from the top and going to the bottom. So this is how it was happening. Right, everyone? I hope you remember this. We were just calling from the top. All these calls are waiting. In my DP solution, I don't want to do that. Using these things, how exactly it's happening, I hope you get the idea. So 2 is dependent on 1 and 0. 3 is dependent on 2 and 1. 4 is dependent on 3 and 2. So if I write this, something like this, I hope you get the idea. DP of 1 is equals to DP of I minus 1 plus DP of I minus 2. The reason I took it as 0 because I'm adding it this time, right? I'm not checking if it is not -1 or something. We can do that as well. But again, the idea is same. If we have 0 here, even if we make a mistake, this adding will not at least extrapolate our answer. We can remove this all. Great. Now, once we have run all of this, where do you think our answer will be? Our answer should be somewhere on this because we want DP of 6. Let's say in this example, it will be here. So 6, right? Let us try to run this everyone now. I am getting 13, which seems to be the right answer, I guess. So 0, 0, 0, 1, 2, 3, 4. Okay, just missed the fifth, sixth one here. Let me remove this. Let us add 5 here. And then, of course, based on our approach, so we took 1, 1 as the 0 and 1 number, right? So many places you will see that the first Fibonacci number is 1, 0th Fibonacci number is 0. We have took both of them first. So yes, we seems to get an answer, but something which I would like all of you to understand. First, we are not using recursion here. And let me now try to help you visualize this. Function gets defined, n equals 6, answer, Fibonacci in the bottom up. I'm calling this function, okay? But this function doesn't call other functions or is not using recursion. Let us move forward. Is n greater than less than or equal to 1? No. So we cannot return 1. I am making a DP array. See this particular array. And now right in front of you, you will see that how these values are getting filled up. DP of 0 I know is 1. DP of 1 I know is 1. Next, for I in range 2 to n plus 1. N is 6. So this loop is going to run for these values. Okay, everyone? So let me just draw this. These are the values which I'm interested in populating. Exactly the way we used to do it manually. Exact same thing is going to happen. We are just saying that, hey, do this now. Do this whole process in front of us. So let us see how this gets filled, everyone. Next, I2, I is 2. See, this gets filled as 2. I3, it gets filled as 3. I4 as 5. I5 as 8. And I6 finally as 13. Once everything is done, I can come out of loop and you can see that DP of this n, which is 6, is 13. And I get my answer as 13. Okay. So again, honestly, if you ask me, you should be aware of both the approaches. Just one downside is there in the memoization approach. And that actually is, let me write it in red. Here, as we use recursion, extra call stack memory is required. Whereas no such dependency or limitation is there in the bottom up approach because we are not using recursion. We are just trying to fill in the answer based on the understanding of our memoization code. In memoization, I also showed you that how, though we start from 5, finally we fill these two, the base cases only first and then try to build up an answer. But in bottom up, we are starting from here only. And as we are not using recursion, okay, it will not have any such issues where call stack will get filled up. Now you don't have to worry or you don't have to always chase the DP solution or the tabulation solution, everyone, because majorly in problems, this code works fine. The way you have to do recursion questions going forward is in this particular manner. First, you will write the recursive code. Then you will do the recursion plus memoization. At this point, you will make the table, okay, and try to fill it based on the exact step or exact order your code is going to fill it. And then finally, we will do the bottom up or tabulation. So we will always make sure that we write 3 codes for our problems in DP where it is dependent on recursion. Okay, great everyone. So I hope this overall approach is now a lot clear. Let me just do one thing so that you understand. Just let me keep all of this a little bit separate from the above. So this is how you have to follow this, and tabulation approach. Great, everyone. So with that, I hope this is clear. Now, in the upcoming videos, I will be giving and discussing questions with you, which we have to make sure that we do in all of these three approaches. Please make sure again to see this video again. For anyone learning DP for the first time, it is a lot daunting initially, but believe me, the way I'm taking time, I want each and every one of you to understand DP completely in depth. That is the reason I am making sure to spend so much time in solving these initial problems, so that the fear of DP doesn't stay with you. And as you move forward solving questions, you are able to take the full benefit of all your knowledge and write DP code very easily. Okay, so great, everyone. Now let's meet in the next video and we will be solving more and more questions, because that is the best way to hone your DP skills. The theory is not there, it's just a way of solving the question, just like recursion. So we are going to do the same thing.